All right, so if you've been using pandas for any amount of time, you might know of an accessor called .loc. And with .loc, we can filter our data based off a single column or multiple columns. Now, the only problem with .loc is that as we make our conditions more complicated or, add more of these conditions, the syntax can get very messy. So I'll show you another way of doing things using a query, and I'll show you how we can handle all different types of data types, whether we're talking about strings, integer data, a Boolean series, and dates. Let's say I wanted to get all people whose first name was John. I can simply DataFrame.query, and then as a string, just ask that the f name is equal to John. And just notice how I've put it in double quotes so that I can compare the string, the string John like this. And this gives us everyone whose first name is John. We can combine conditions as well, so I can get people whose first name is John and their age is 20. Now this will give me both of them being true. What I can also do is ask that the age is not null. So that's another thing we could potentially do. So let's say I want age dot not NA. And this gives me all the ones where the age is not null. If we want to find the ones that are null, we can use is NA, but there are none. All the ages are filled in. If we look at our data again, we can perhaps move back to our string columns and ask that the last name ends with SON. So, Henderson, other names like that. So .query, and we can use, take our lname column, .string, because we want to use a string method, and the string method that we want to use is ends with, and we want it to end with SON. And you'll see here that Python tends to freak out a little bit because it doesn't really know what to do with all the quotes here. So let's just make sure that the outer ones are in double quotes so that we can easily pass in single quote string over here. And this will give me all the people whose last name is ending in son. Let's now look at maybe all people whose addresses had the word plaza in it at some sort of stage, whether it's at the start or the end. So instead of ends with, we can use contains and just ask for plaza like that. And it doesn't look like anyone, address. We want the address to have plaza in it. So let me just put address in there. And this gives me everyone whose address is plaza. And just remember, we can combine this with other conditions. Let's say I want the age to also be 18. It doesn't matter whether we're making a string comparison and we're imposing some integer conditional as well. It doesn't actually matter. So that's another thing we can do with .query. Let's say we want to compare one column against another. So let's say we want to find people who are older than their siblings. So we can df.query, and with df.query, we can ask that the age is greater than the sibling age. Like this. And straight away, you see that Python freaks out. Invalid syntax, end of the world. Now, if we're dealing with a column that has a space in it, all we have to do is just put this one in backticks, like this. And that will tell Python, it'll tell the query method that we're dealing with a column called sibling space age, and everything is fine after that. So these are people who are older than their siblings. Let's say we want to run a condition on this Boolean series. Let's say we want all people who have a pet. All we have to say is has_pet is equal to true. And here we can handle Boolean columns as well. Okay, if we take a look at our data, and let's just say, let's grab the date responded and grab all the unique values just quickly. We see that we have people who did this survey on the 31st of March and people who did the survey on the 1st of April. Now let's see if we can filter all the people before April. So we can say df.query, and we want the date responded column to be less than April 2023. So we can say, maybe something like, if I put this as April 2023, we can probably do maybe 2023 04 and see if that works. Which it actually does. So it makes, you put it in a string, but it does know to compare it against the date, April 2023. So we get only the people on March 31. Cool. Another way we could do this is we could try, to set it to a date time. So we could say pd.toDateTime, and let's say we wanted to pass it in as a string. So perhaps maybe we wanted to do something like this, like April 1, 2023. So we want all people before April 1, 2023. Unfortunately, this doesn't work. It doesn't quite understand what pd.toDateTime is, but a workaround for this is that you can actually store this in a variable. So if I store this in a variable, April 2023, like this, and I call this like cutoff date, I can actually paste cutoff right over here. And you see that this still doesn't work. The last thing that we have to do is just whenever we reference a variable such as cutoff, just put an ampersand, not an ampersand, but one of these @ symbols at the front. And that will do the same sort of thing. Okay, so let's say we want to also maybe find people whose age is equal to the mean age. So we can find out what this mean age is by doing data frame. Let's get the age column dot mean, and we want to find people whose age is equal to that mean age. So df dot query, and we want to see the people whose age is equal to the mean age. Cool. And the reason why this doesn't work is because if we have a look at the mean age, it's probably a decimal of some sort. So yeah, it's 18.53, and all these ones are integers. So that doesn't work. But, if we hypothetically had an age that we wanted to look at, so like age is equal to 17, and we wanted all people whose age was this value, we could just do that and we get no problems. So here are some of the ways you can use query. It just neatens up your syntax a bit, and it saves you from, having like very, very complicated .loc statements where you have like lots of nested bracketing and things can get a bit out of hand. So yeah, that's it. Give it a try and see how that goes.